In this video, I am going to expand the function 1 by z square plus 1 into z square plus 2 in Laurent series. The given region A, B, C. First of all, let's take the region A 0 less than mod z less than 1. F of z is given by 1 by z square plus 1 into z square plus 2. We can write it as 1 by z square plus 1 minus of 1 by z square plus 2. If we cross multiply this, we get z square plus 2 minus of z square plus 1. That is minus z square minus 1 divided by z square plus 1 into z square plus 2. This is z square minus z square. 2 minus 1 is 1. So we can write it as 1 by z square plus 1 minus 1 by z square plus 2. So f of z is this. Now this is our region 0 less than mod z less than 2. 0 less than mod z less than 1. That is mod z is greater than 0 and mod z is less than 1. The positive quantity which is less than 1 means mod z square also less than 1. This is mod z is between 0 and 1. Mod z less than 1 means it's square. Mod z square also less than 1. Then we can use, this is 1 by 1 plus z square. We can use geometric series. 1 by 1 plus z is equal to 1 minus z plus z square minus z cube etc. which is valid for mod z less than 1. Then instead of z, we put z square since mod z square also less than 1. We can use this series. So this is 1 by 1 plus z square is 1 minus z square all square minus z square all cube plus etc. which is valid for mod z square less than 1. Now the second term is minus of 1 by 2 plus z square. Take 2 outside, that is 1 by 2 into z square by 2 plus 1. This is 1 plus z square by 2. If mod z square less than 1, then mod z square by 2 also less than 1. This is half of this, which is less than 1 by 2 and less than 1. Mod z square by 2 also less than 1. So we can use the same expansion of geometric series since mod z square by 2 is also less than 1. So this is 1 minus z square plus z raised to 4 minus z raised to 6 plus etc. minus 1 by 2 into, this is 1 by 1 plus z square. That means 1 minus z square by 2 plus z square by 2 all square minus z square by 2 all cube etc. So we can write it as series n equal to 0 to infinity minus 1 power n z raised to 2n. This is all even powers. Z raised to 2n minus 1 by 2 series n equal to 0 to infinity minus 1 power n. This is z square by 2 all power n. So we can combine this. We get f of z is equal to series n is equal to 0 to infinity minus 1 power n z raised to 2n, that is we got z raised to 2n and here z raised to 2 all power n is also z raised to 2n. So z raised to 2n minus 1 power n is common and here 1 minus 1 by 2 and here also 1 by 2 raised to n is there. So combined we can write as Z raised to 2n is common. We can write as 1 minus 1 by 2 raised to n plus 1. So this is our series valid for 0 less than mod z less than 1. Now second, B 1 less than mod z less than root 2. We have our f of z 1 by 1 plus z square minus 1 by 2 plus z square. This is our f of z. Now we have mod z is greater than 1. That means 1 by mod z is 1 by mod z is less than 1. Also mod z less than root 2 means mod z by root 2 is less than 1. Here we have the term z square. 1 by mod z is less than 1. Then 1 by mod z square also less than 1. Its denominator is increasing means the term is decreasing. 1 by mod z is greater than this term. 1 by mod z square also less than 1. Also, if we square this term mod z by root 2 into 1 by root 2 means root 2 into root 2 is 2. Mod z by 2 which is also less than 1. So we can use this is 1 by take z square outside. This is 1 by z square plus 1 and minus take 2 outside. So that we get z square by 2. So this is 1 by 1 plus 1 by z square. We can use geometric series since 1 by mod z square is less than 1. And this is 1 by 1 plus z square by 2. Also we can use geometric series expansion since mod z square by 2 is less than, this is square. We squaring the term. Mod z is less than root 2 means mod z square is less than 2. That is mod z square by 2 less than 1. So we can also use series expansion. So this is 1 by z square into this is 1 by 1 plus 1 by z square, that is 1 minus 1 by z square plus 1 by z square whole square minus 1 by z square whole cube plus etc. minus 1 by 2 1 minus z square by 2 plus z square by 2 square minus z square by 2 cube etc. That is, this is the series. Series n is equal to 0 to infinity. This is 1 by z square, 1 by z raised to 4, 1 by z raised to 6. So 1 by z raised to 2n, n is equal to 1 to infinity, 1 by z raised to 2n. So that first term is 1 by z square and alternative plus and minus. We start with n is equal to 1, so put n plus 1. So that first term is positive, second term negative, and so on. And minus 1 by 2, the series n is equal to, we can write 0 to infinity since starting term is 1. Z square by 2 all power n minus 1 power n. Since first term is positive and we start with n is equal to 0. So z square by 2 all power n minus 1 power n. This is the series expansion in the second region. Now the third one, mod z greater than 2. And the function is given by 1 plus z square and 1 by 2 plus z square. So this is mod z greater than 2. That means 2 by mod z is less than 1. 2 by mod z is less than 1. 2 by mod z less than 1 means we can take 2 by mod z square also less than 1. Since denominator is increasing, the term will decreases. 2 by mod z square also less than 1. So take z square outside. As done earlier, 1 by z square plus 1 minus 1 by, take z square outside. This is 2 by z square plus 1. Now this is 1 by z square into, use geometric expansion, and minus 1 by z square, all cube etc. Also minus 1 by z square, 1 minus 2 by z square, plus 2 by z square all square, minus 2 by z square all cube etc. So this is 1 by z square minus 1 by z raised to 4 plus 1 by z raised to 4 to 6 minus 1 by 6 to 8 etc. This is minus 1 by z square plus 2 by z raised to 4 minus 2 square by z raised to 4 to 6 plus 2 cube by z raised to 8 etc. That is the series n is equal to 1 to infinity 1 by, this is 1 by z square, all even terms, z raised to 2n, 1 by z raised to 2n minus 1 power n plus 1. Since starting term is 1 by z square positive, we put n is equal to 1, we get minus 1 square positive. Second term, take minus common outside. The remaining is n is equal to 1 to infinity. Since starting term is 1 by z square and all are even powers of z. This is 1 by z raised to 2n. Also minus 1 power. Since we take minus outside, starting term is positive. So this is n plus 1. Also there is powers of 2. Starting term is 1. So that 2 raised to n minus 1. If you put n is equal to 1, first term 2 raised to 0, 1. And so on. So we can combine this series as, it is equal to series n equal to 1 to infinity minus 1 power n plus 1 and 1 by z raised to 2n is common, 1 minus 2 raised to n minus 1. So this is our series expansion valid for mod z greater than 2.